Now that we have a better understanding of how fractions, percents, and decimals are related to each other, let's look at the situations where we use those equivalent representations for us to do mental math and estimations. And so sometimes these problems seem overwhelming, but if we know the percents and the fractions that are represented with those percents, it makes it easier to estimate. And so you have these fractions and then that are equivalent to these percents. And then what we know is then that we can treat these fractions kind of like a division problem. So 25% of 44 would be the same as taking 1/4 of 44, so it's 11. 75% of 24 is 3/4 of 24, right? And so looking at that, you can see what you could do is 3/4 of 24. You can start to make that over 1. 4 goes in that 6 times. 3 times 6 is 28. So ways to estimate. 50% is a half. 33% is a third. And this one, these are interesting ideas here. Doesn't seem intuitive, but 38% of 50 is the same thing as 50% of 38. 84% of 25 is the same as 25% of 84. And so what we're looking at in this case is, if you think about it, right, you can use those to solve. 38% of 50 is the same as 38 over 100 times 50, which is the same as 38 times 50 over 100 if you needed to do that. And so that's why we're allowed to interchange those percents. It's kind of a cool little trick. 38% of 50 is the same as 50% of 38. And so you get the same answer, 19 and 21. It's a nice number trick. It's not a trick, it's just using from associative and commutative properties of multiplication, knowing that a percent is a fraction, and then you solve it. You can do it that way. Nice little trick there. Here's some more problems here used to estimate. Turn the 48 to 50%, turns the 73 to 72, and look at the different ways here. 32% could be close to 33%, 95 to 93, a third of that. We're just using this to estimate again. So you convert them into compatible numbers, right? You change those to something that is compatible to you, right? Compatible numbers, and so you can see the different answers you get. Again, a little bit harder here. If you look at some of these other ones, I would turn this into 130. Exactly 130 times 50%, right? Just put stuff close to it. 0.45%. You can see something like that there. How that gets changed by moving the percents around or estimating them. And so that's a good way to look at those problems.